Hello and welcome to yet another lesson. This time I'm gonna teach you how to handle files using Python programming language. So basic operations like reading a file, writing and creating a file, and changing the contents of file, like appending to the end of the file. We also will go through how to handle URLs. So basically, how to load stuff over the HTTP or HTTPS connection. So basically, doing a bit like acting like a web browser does. And we also talk a bit how to handle JSON data and what on earth is Pickle and serialization. So quite a lot of topics for one lesson. Let's start going. So uh, when you open a file in Python, you usually use the built-in open function. It's also possible to use a function called file. I think it's still an alias name for it, but I just, for sake of that I always use the same way, I will use always open in my documentation. By default, if you don't provide it with this mode argument, it is using the text mode, and this is very important for you to understand. If you are using especially a Windows and Linux computers, this behavior is a bit different over different operating system. But if you want to make sure that you are able to also handle binary data, remember to then open files in binary form if they are binary files. What's the difference between text file and a binary file? A text file basically only contains text. Most of program code files, for example, are text files, but binary data can contain any combination of bytes and bits. For example, a zip file, an executable file, or an image file, and so on. And the basic pattern for file handling in Python is that first what you do is open, and you provide the path where you open the file. Notice that while you write this file path, I recommend you to use always the slash and not backslash, even if you are using the Windows operating system, because in Windows operating system this pretty much works as a replacement of backslash as well. Because if you use the backslash, then you need to be careful, because notice that backslash is the escape character in strings. Maybe you then want to use raw strings. I don't want to get too complex here, but if you're still a bit uncertain how to handle these file paths, then you need to delve into a couple of additional modules how to do it. But basically the modes here, the second argument, R is default, meaning reading. Then we have W, which means for writing. A is for appending, which means add to the end. Then it's the same with the letter B, meaning it's the same in binary mode: read binary, write binary, append binary. And then if we put the plus sign, it means for both reading and writing. And this is for both reading and writing for binary files. And this is actually still both for reading and writing, this W plus. So I don't actually see any difference between this R plus and W plus, but this A plus is slightly different because it's appending to the end plus opening for reading. A bit confusing. After you have opened the file successfully, you can do your file processing, you can read the file, you can write to the file, but then you should also remember to close the file. What happens actually is that when you, for example, write to a file, it often didn't actually yet write to the file. Even though you explicitly wrote in your Python code that said write, it behaves in similar way like C programming language does. If you have used some other programming languages, they also in general do so that they don't actually yet write when you said write. They wait until there is enough data in the RAM buffer, and then it flushes the changes there. To make sure that you will flush all the changes there, you should remember to close the file, because the moment you close the file, it flushes all the changes it hasn't yet done so. But even when you say this F close, it's not yet guaranteed that all those bits are truly written all the way to your hard disk. Especially nowadays, if you look at many of the bigger hard disks, they are still not SSD hard disks. They are these physical rotating disks. I, for example, have, was it 12 terabytes on this computer, and it doesn't matter. They have quite large cache RAMs. They have like 64 megabytes of cache, sorry, gigabytes of cache RAM. So it first writes everything to this, doesn't matter. Anyways, everything first is written to this RAM memory inside that hard disk before it actually gets written to those rotating platters. So it's quite difficult actually to know when everything is written all the way to the file level. I don't on this video even gonna show you the example to how to do this hard level file sync, which should sort of guarantee that it is finally written there, but even that can't be 100% sure. So it's more complex thing than what you think. But now you at least understood that even though what you write in this file handling is not everything, so but basically the pattern is very simple. You open a file, you do something with it, then you close it. And so that you don't forget to close it, I always recommend to use the with pattern instead. So with open, we are gonna open the file with the mode, and then instead of assigning it to a variable like this, we say as f. So this file handler value is now assigned to the variable f. So it's basically same as this open, and here you do the file processing, but you don't need to close the file because this with creates a new block, and this variable f no longer exists outside of this with block. So when the with block ends, this variable f is automatically garbage collected from the memory, and Python will close the file for you. So this will save you one line of typing, plus it's sort of more secure way, because humans tend to forget things. I at least often forget to do some important things. It would be nice like there would be some automatic program. Every time I leave the house, it will always remember to close the door unless I'm just going to the yard. But if I'm just going to the yard, how does it know? Anyways, bad example. And once again, when you're trying to do something with files, of course, that can cause a lot of different kind of exceptions. And in Python 3.4 and later, they are underneath OS error, but in earlier Python versions, they were so-called IO errors. So if you see some older Python code and it uses this IO error, don't be confused. Nowadays, it's OS error. And in my material, you should always now see this OS error everywhere. Let's first show you how to open a file. As you can see, it's not that difficult. The first one will open the file called test.txt in the same directory, and it will try to read the entire file into RAM memory. Notice if the file would be massively big, let's say it would be many gigabytes in size, this would probably take a while, and it might not even be a good idea if you are working with a computer which has a restricted amount of RAM memory available. So sometimes it might be better to read line by line. And that is exactly what is happening in the second example. And to read line by line in Python is very easy to use just the for loop. So we can actually iterate this file handler for line in f. When you are handling text files, what you need to remember that this line actually also includes the line break at the end of each string. And when you print them out, unless you want like double line breaks, because the print also automatically inserts one, then you want to right strip it first, like I'm doing here. The third example is using the read lines, which reads all the lines of the file into RAM memory, but instead of turning them into one string, it turns them into an array of string where each line is a separate item in that list. And we are once again going to use the enumerate now to enumerate the lines numbers from 1, 2, 3, and so on automatically here. Let's demonstrate these in action, so you will see how they actually work. Do I have actually the test.txt here? Let's first test it. That is, do we? Yeah, we have test.txt, and this is a good file because here we have actually line number 1, we have the second line, the third line is fully empty, that's a good thing, and then the fourth line has some special characters like a and this is very useful. When you are testing that does your program code work, you should do stuff like this, maybe create intentionally an empty line, and here also I put this a and which are not ASCII characters, so just to check that everything works well. Okay, the naive way to do it was using this. We didn't use the with statement, and let's run this piece of code. And okay, it didn't find the test.txt. It's trying to run it somewhere. So let's run these codes actually from here, even though this is now in Linux. So now we are gonna just say it was this Python 3 and then this read file 1, and as you can see it printed it out, and this read file 2, this will do the same, but as you notice it's one line less program code, so I prefer to do it like this, and it will once again work very well. Then we have the read file 3, this is the same as in my PowerPoint, so let's run this one, and as you can see it worked very nicely. The previous ones printed out an extra line break, because if we go back to this like read file 2, this print itself, if I don't give it like this end is empty, it will create one extra line break. If you want to avoid it, you just write here that this end is empty, and that's it. So now I can fix this problem. So actually, sorry, I actually modified the one which is in Windows. Let's modify the one which is here. I'm gonna use just Emacs. I'm too lazy to do this in this. Actually, yeah, now you see how to do it in here, so it's not that difficult editor to use. I just type end. I don't actually, by the way, have any extensions in this Emacs, so this is just out of the box Emacs. I saved it, and let's run it again. And now you can see previously it printed out this one extra line here, now no longer does it. So quite easy to fix that problem. But let's look at the this one here. This will enumerate the lines. Here I did it that n is 1, and I manually do this enumeration, but this is not very good way to do the things, so I don't recommend to program like this. And as you can see, it gives the line numbers there. It works, but I would consider this number 5 better, because now I'm using the built-in enumerate here, which will do this enumeration, so giving the line numbers automatically for you. I can even give from which number it is starting. It's by default starting from 0, but now I tell it to start from 1, and as you can see, this read file 5 will give me these results. So that was how to read files. Let's go on, so because we still have quite a bit of stuff. What about writing to a file? Okay, if you use the W mode, this write mode in Python, what it actually does, that it first checks does this file exist or not, and if it doesn't exist, it creates that file. And if the file did exist, if there was previously a file test.txt, it actually deletes its content. So be careful with this write mode. It really gets rid of the earlier content what you had in this file. It doesn't ask any silly questions like should I overwrite or not. It just will overwrite. The first example here is just writing 2 lines of text there. In this second example, we are going to provide it with the encoding. By the way, to my memory, it is by default this UTF-8, but you can change the encoding here if you would want to use something else, but UTF-8 is by far the best encoding for text files for multiple reasons, so I would recommend always to use it. And here we are actually gonna put there something. We, for example, put there, now we use the write lines here. So write lines is actually the same, it's like the equivalent of these read lines, which returned a list of strings, each line of that file as a string. So here we have each line of that file as a string in that list. So now we provide the list here, we just put there 2 lines. It's also possible to write to a file using the print command. We just provided that it's outputted as file f. And now we are going to write there something which has some special characters. We have this, which we often use in Finnish language, this a and then it reads in Russian language privyet, and here in Chinese it reads ni hao. They, by the way, all mean this hello, basically. And this is once again a nice way to test that do all these special characters actually work, because it's quite often that some programmers, they're just doing this and they never test it. They never think that somebody could use this Cyrillic alphabet, because even though there are actually a couple of 100 million of people who are using this Cyrillic alphabet, not to mention that there is like at least 1.4 billion people who are using these Chinese characters. So obviously you should test that your application doesn't break even if the user will use some Chinese input. And now if you're wondering that I don't know how to type in Cyrillic, or I don't know how to type in Chinese, you don't need to. You just go to internet, search a web page which has something in Cyrillic and something in Chinese. You just copy and paste it, and that's how you can check it if you don't know how to type it on your keyboard. And fourth and last example, we have actually, this is the most interesting example here, because here we have an endless loop and it says give me a line, and it asks these lines until the user just gives an empty line when it stops. And if you remember, this with statement always automatically closes the file, and now it's writing to a file. But what we now need to understand, no matter which one of the you use this fwrite, or you use this write lines, or this print, it actually not yet write to the file. Let me demonstrate you this. So let's first run this first, let's for example this one which will write this hello and this privyet. There it is write file, I think write file 3. Yeah, let's run it. I'm not gonna run all of these because you can do that on your own time. So we go to write file 3 py, and now this test.txt, sorry, actually it has different content now. Let's write file. Yeah, it put this sorry, I needed to go to this write file 4 to write this hello and this. Let's run this write file 4. Sorry. Yeah, this one. And now let's say, sorry, cut test.txt. And actually it's, this terminal is unable to display these Chinese characters. That is an interesting thing. Maybe I should configure it better. These Chinese characters are often a bit problem for this. Some of these Linux software, they don't automatically handle them as well as it would, but the Cyrillic and and was handled nicely. But this is completely unreadable. But this is not my Python program's problem. It is the shell here is something wrong with the setting here. I will not now go to check it. But let's go to this write file 4. And for this demonstration, I now need to open yet another one. So I now have 2 windows. And I will go navigate to the same directory. I will go to this Petri Kuittinen assignments, and I go to lesson, Python, file and web. Okay. And I'm gonna say here often this cut test.txt. So now it still has this content, but look now what happens. So what we are now going to use, we're going to use this write file 5. So write file 5 is asking the user, let's say Python 3 write file 3, and give me a line. I will just give, for example, first line. And let's now look what this file contains. It contains nothing, and even if I will use the ll command, it tells that it has 0 bytes. So what happened here, this first line just truncated the file to 0 length, and even though I already inputted here first line, nothing is yet written here, nothing. I will write here something more. I will say second line, much more text. Let's put an awful amount of text and empty lines, and finally now something is here because I accidentally put the empty line there because that ended it, and it is finally there. But nothing really happens with this program until I actually exit it, because everything what it is writing here, it's writing to RAM memory and not to the file system. If I would eventually write there enough, like I don't know what's the size of the RAM buffer, maybe it's 64 kilobytes, but my fingers will get already sore to type 64,000 characters. So how to fix this problem? One way is to use this flushing thing. So now I'm gonna teach you a new thing. I will just do exactly like I did above, but I will just say flush is to. And what this flushing means, every time it is writing, it's actually flushing these changes to the file system. Now you will see a big difference. Sorry, I was now modifying the code here. I need to modify it first here, damn it. Now it gets a bit complex, but I will just once again do it this with Emacs. Okay, so I will just comment out this line and use this line instead. So just save it and let's try it again. Write file. And the moment now, once again, if we go to this different window, you will see that it is 0. There is nothing there yet. But now if I will write here, this is the beginning, and I will press enter. Now let's look at the size of this file. As you can see, it is already 22 bytes. And if I will show its content, this is the beginning. So it really wrote those characters there because now I use the flushing. And let's put here second line, and let's print it out. And yeah, the second line is already there. So this tiny change also how this program is behaving. Now it is instantly refreshing the changes. No, not instantly, but you get my idea. Now I'm gonna quit it here. And of course, then it will do the flushing as well. Let's continue next to appending to a file. This is same as reading a file, but if this file doesn't exist, it creates a new file, so it works exactly like this W mode. But if the file already exists, it keeps all the previous content of the file and it appends the new data to the end. So here it exactly does like this. One more line. It will keep all what it is there and it will append it to the end. Let's look at, for example, this append file 2, and let's run it. So now the content of this file, this test.txt, this is the beginning and second line. And now if I'm gonna use this append file 2, I'm gonna actually run it instead of just printing it out. I'm gonna write it. And now it should add one more line and the line ending. Notice this \n is the line ending. Now it should add it there, and sorry, this is exactly what happened. And if we will run it again, it will keep adding it. So once again, one more line. So if we run and run it again, it doesn't delete the stuff what is there. Now, okay, sometimes you would want to change the contents of the file somewhere else, not just keep adding stuff there. How we can, for example, write to the beginning of the file. It is possible to do, for example, like this. You can seek to the beginning of the file and then put a new line there. And notice before here I read the entire contents of the file, and then I will write it to the end. So now it keeps everything, but now it adds to the very beginning. So appending to the beginning of the file, which is this cut append file 3. Let's run this cut append file 3. From here, Python 3 append file 3, and let's now look at the contents of this test.txt and new line to the start. So now it added to the beginning. So now I demonstrated you how to add to the end, and with this seek command here you can actually go to any part of the file which you want. Now, okay, I didn't yet show you how to handle these binary files, but we will come to it because the next slide is about reading and copying data from URLs, and this URL basically means web addresses, and here you will also see the binary mode happening. So to do this thing we are using a built-in library called urllib_request, and this is a very handy library, one of the most useful libraries I found from the Python standard library, and it works just like reading the files. So if you now understood how to do it with files, exactly same pattern works with these URLs. And now we are trying to read a web page from this address. This is in Finnish language, it's news, and we use the same pattern. So instead of the command open, we use URL open, and we give it the URL, and then instead of F we just wrote like a response, and we try to read it all. But since this always returns a binary bytes construct, in order to turn it into a more human readable string, because this is an HTML file, we try to decode it into UTF-18. And instead of printing out the entire web page, which is probably a bit too much, we're just gonna print out the first 1000 characters. Let's see this in action. So we have the URL, was it read URL? Yeah, this one. Let's try this one. So let's first actually open this to a web browser, so we can. No, let's first run it from the Python code. Then we can do the interesting comparison. So we say Python and read URL, and it prints out the beginning of this HTML file. As you can see, it printed out doc type and then a bit of this HTML code. Not much. It didn't print out the entire web page. Now we can actually go and check is it the same if we go now to this same address, this www.yle.fi and this uutiset, and I press Ctrl U in this web browser and I zoom a bit, Ctrl plus, and now we can compare, does this actually look the same? To my eyes it really looks the same, so we can read it. But what about binary files? For example, let's think about an image file. Here we have an example of how to do it with an image file. We have the reads URL. We are trying to reach this shortened URL, and what we are doing here, we read the entire contents of this bitmap image file into a variable called data, and then we are opening a file called cat.jpg for write binary mode. Notice now that you need this letter B because this is a binary file. All JPEG files, all PNG files, all normal image files, they are binary files, and then you just try to write it. So we read something from the internet and then we try to create it. Let's see if it will run it, it actually wrote something there, but I didn't see anything happening here. Let's actually go here, because here we can probably see something happening. And so if we you see I don't have any file called cat JPEG here, but if I will now run this Python 3, this read, I don't know why in this Visual Studio Code it now is using some weird directory where everything is happening. Ah, now I know what's the reason, because I have multiple directories open. It probably meant to the root of all those files. Now I understood. I should have just opened a folder. I opened multiple folders in Visual Studio. No, stupid of me. Let's still do it from here. So I will just do it, read earl2, and now after this, if I will print out this listing, now we have cat JPEG, and I will just copy this cat JPEG, for example. Let's copy this file to the root of my E drive, so we can actually now go to E drive, and we have cat JPEG, and indeed this is the cat picture we copied now from internet. So you can use this kind of program code not just to copy cat pictures from the internet. This same pattern of code you can use to copy any kind of data from internet. So it can be a video file. In fact, this very popular program called YouTube DL, which I have often used, it's to download YouTube videos. It's, by the way, the best program for that. It's a command line application. It's written in Python, and as you know, YouTube is also written mostly in Python, but you can use it to copy MP3 files, executable programs, whatever. So anything works with these very simple patterns. And since it is really so easy to go through these different web addresses and copy a file from there, you can imagine the reason why, for example, the Google founders, Larry Page and Sergey Brin, in 1998, when they launched Python, they originally, Google search engine, they created the Google search engine using Python programming language, because Python already back then, over 20 years ago, had so easy to use tools to do these kind of tasks. I even created here a bit silly example called bad browser. So this is the sort of world's worst web browser. It basically only asks this URL, and then it will display the first 1000 of it. But it also uses this cache. So it has built-in cache memory. If the cache is just 64 items in size, it's very small, but it remembers. If you try to run the same URL again, it will do it much faster, because it gets it from the RAM memory. Let's actually try to run this program now. So we need some URLs. Let's, for example, try this news. And this would be a good one, and let's, for example, now try give me URL, and now it printed it out. Now if I will try to do it again, this same URL, you can see it instantly gave the result, because it was already there. But if I will try to now load a new one, let's, for example, I will go to python.org. Once again, it needs to load this, so I will give it python.org, and it will give me python.org. But if I will type python.org again, it does it instantly, because it comes from RAM. So this example showcases how easy to even build such RAM cache in Python, just using the built-in least recently used cache decorator from the functools module. So it's super easy, and of course you can make this cache much larger than 64. You could make it like 1,000,000 if your computer has a lot of memory, and then it will run actually quite efficiently. But of course it's still not a real web browser. It's unable to provide you with the decent user interface and navigation, and doesn't show you any images, and yet it would be quite a lot of work to do a proper web browser, but it would be actually very good exercise. Few things still more. One of the things I want to talk about is JSON, which is short for JavaScript Object Notation, and how to use it in Python, and then Pickle. let's first go to this JSON. So JSON is short for JavaScript Object Notation. This is basically the de facto way of storing and transmitting data nowadays in the World Wide Web. So almost all the major web services, they use JSON instead of some other format. This was originally invented by a guy called Douglas Crockford, or Crockford actually, who is actually, he's a very smart programmer, and he's actually, I think he's older than me, but I value his video lessons. If you're interested, he has done many nice lessons about JavaScript programming language. He used to be the JavaScript guru who worked for Yahoo, which was back then the most important internet company in the world. So he worked for Yahoo and he created this JSON. JSON is basically just a subset of JavaScript. So instead of coming up with a completely new syntax, he decided to use just small part of the JavaScript language. First of all, we have an object, and this is very similar to Python dictionary. The syntax is almost exactly the same. We have these curly braces, and then we have strings. The only keys can be strings in these objects, and then we have a white space, and then we have the colon, and then we have the value. And then we have arrays, and we have values which are separated by this what is this called in English? It's called comma. No, anyways, this is very similar to Python list. So these objects are like Python dictionaries, and arrays are like Python list. And this is not just pure luck. The creator of JavaScript programming language, Brendan Eich, he says he likes Python programming language very much, and since Python is more older programming language, he has copied a lot of stuff from Python. So if you know JavaScript, it's not that difficult to learn Python, or if you know Python, it's not that difficult to learn JavaScript, because there is quite a lot of similarities, and not just in syntactic level, it's just more or less in this philosophical way. And then we have the value. In JSON, the values can be strings, numbers, objects, arrays, or special values, true, false, and null. The strings can of course be any like normal JavaScript string, and we can use the escape notations like n for this line feed character, and then we have the numbers, which are just same as, I don't know why this web page shows it's weirdly huge. Maybe I should open it in a different web browser. It is really showing this. It is still showing the documentation massively big. It is, even though I have 4K resolution, it looks a bit weird. But anyways, you can go to read it yourself, this documentation. So this is basically all you need to know about JSON. And as you can see, JSON is supported by all the major programming languages. For some programming languages like JavaScript, the support is already built in. Same for Python. There are some additional Python modules, but the Python standard library comes with a very handy module called JSON. So JSON is just a standardized way to store data. And how to use JSON? Here we have 4 different examples. Let's look at these particular examples. So the first example here is we just have a Python dictionary. We have some data here like name and example and number and blah blah blah. And if we want to, this almost already looks like a JSON, but it is not a string. If we want to save it to a file in JSON format, notice that I recommend you to use the JSON file ending. It's so easy that you just use this JSON dump. The first argument is the data and the second argument is the file handle, and then you can just print out JSON data saved. So few lines of code and you have you can put any Python data structure, basically, no, not any, but such compatible data structure which can be converted to JSON and write it to a file. To read it from file is you just use JSON load. But if you're operating in the web, you often don't want to save into file. You instead want to operate with strings. Your piece of code which is running in this web application server, it's getting a string in JSON format, or you have a data in JSON and you want to get it to string and so on. So the conversion is dump S and load S. So it's almost exactly like here, only the letter S is signifying that instead of a file, it is a string. Notice that when we convert this Python piece of data here into JSON string, its ordering is not necessarily guaranteed. Notice that here this comes like this, at least when I was running this code. But anyways, but most interesting is that this a and since these are not ASCII characters, they are written in this Unicode way here. So this is actually example. Here is a and here is so these are a and o umlauts are handled in, but this does all the magic for you. So it's super easy to use this JSON. And what is nice about this JSON is that a lot of software nowadays uses JSON to store something, for example, like configurations. If you use, for example, this Visual Studio Code, all these settings you use here, you do go here and manage the settings here. All these settings, they are actually saved into JSON files. And since this JSON is such universal format, it's not tied to any specific programming language. There exists modules to how to do this JSON data with any programming language. It's nice, and it's nice that pretty much every website also uses this JSON format. So it's like a common agreement. Instead of everybody inventing their own way of doing things, they use JSON. Now, there is a competing format to it, and that competing format is basically called XML. XML is short for Extensible Markup Language. Now I don't have time to explain you more detail what is XML, but XML basically, it looks very similar to HTML, but you can like invent your own tags there. And when XML was invented in the late 1990s, it was super popular and everybody was using this in the internet as well. And they even thought that this will replace the HTML, and they created this weird version of HTML called XHTML. But let's fast forward this history lesson. Why then JSON won? First of all, this XML is more difficult to understand than JSON. So the documentation for XML is, it's not just like one short web page. It's much longer. It is more complex to understand, and to make matters worse, it's much more complex for the computer to parse, which means decode and encode data into XML format. This parsing and this decoding JSON is like 100 times faster for the computer, and that really was the key reason. People value speed over pretty much anything else. So if your website is running 100 times faster, it's good. Imagine if, for example, it would normally take like half a second for your website to display your web page because you use JSON, but you instead decided to use XML and now it's 100 times slower. This would mean that it would take 50 seconds for it to load just one web page. Nobody would want to use that. 50 seconds is just too long time to wait. So the reason why JSON won over this XML format, XML is still also used by some software, but when it comes to World Wide Web, when it comes to web pages, this XML has almost everywhere been replaced by JSON, because JSON is just so much more handy. Still, one more thing I want to show to you, and it is called Pickle. And before we go to this Pickle, JSON has one, and actually XML both have one key weakness. Neither of them is designed to handle binary data. Notice that if you remember the different types of data this JSON was able to handle, I'm actually now going to zoom out this web page. It is ridiculously large, this image. It is truly weird web page. Anyways, why it displays this image in such massive way? Even if I zoom out this web page, it is able to handle strings, numbers, objects, arrows, true, false, and null, but no binary data. So, for example, if you would want to store, let's say, this JPEG image of cats inside this JSON, there is no easy way to do it. You need to first encode it into a string, and to encode binary data into string is not efficient at all. You will waste a lot of data and waste a lot of processing power. XML is even more problematic because XML it doesn't even distinguish between numbers and string. It just understands strings, so everything is string for XML. So XML in a case it's even worse than JSON. But neither of them handle this binary data well. But there are occasions when it would be useful to handle binary data as well. And then this Python Pickle module comes to rescue. Pickle is as easy to use as this JSON module, but it implements a binary protocol. Notice this is now Python language specific. So if you are using this to serialize your data, and serializing means that it will convert your data into such form which is easy to store and easy to read. You can not do this if you serialize it, for example, using Pickle. I don't know how to open it with if you write your program in Java or some other programming language. So basically now you're stuck with Python related things. But it's really easy to use. So once again we see input Pickle, and then we have some Python data. It supports pretty much any type of Python data, and if we want to save it to file, we say my data Pickle. You don't need to have the file ending to be Pickle, it could be anything, but I just selected the file ending to be Pickle, and we of course binary mode, and we are gonna dump it there, and here we do the opposite, we read it back. Let's now demonstrate this piece of code in action, and let's go here. So we have these examples. Is first this Pickle example 1, and it will save it to file called my data Pickle, and as you can see here is no my data Pickle, so we don't have any my data Pickle here. But after we run this piece of code here, now if we type my data, and now we have also my data Pickle. And if we want to look at this my data JSON is still human readable because it's JSON, so it looks like this, but it's at least a bit human readable. But if I will look at what is this Pickle, it will probably give me, yeah, it's a binary file. It is still somewhat human readable, but it is not meant for human beings to read or write. This you could even edit by hand. Notice this JSON. You could just take a text editor and you could change it using a text editor, but to handle this in a text editor it's not feasible, this Pickle data. But I can be able to read back this data using now this second example, which is this Pickle example 2, where I'm just reading it, and let's run that piece of code. So I will say Pickle example 2, and it's able to reverse this data. And when to use this Pickle, I now give you a couple of concrete ideas when this would be useful. For example, let's assume you would write some cool piece of software like a computer game using a Python. Then you could use this Pickle for the save functionality of the game. You would only everything which is related to the game state. So for example, where your character is located and all the level data. Maybe the level is it has some like walls which are destructible. You can destroy some of the walls. You can pick up some items. All this is in one data structure, and you will just say Pickle dump to file. And to load this save files, you just say pickle load. So few lines of code and you already have a save and load functionality for your game. Very handy. Another thing is that what you could do is that you will store them in the database. You will use this binary large object blob, and then you can put any sort of data inside that, like MySQL database, and retrieve it back from the database, and this will work very, very nicely. But for all these other means, when you're not needing so much of these binary things, when you're just happy with text, I recommend to use JSON instead, because JSON is de facto standard. Pickle is just used by the Python people, but JSON is usable from any programming language with relative ease, and it's the de facto way to do things in the internet. So once again, I hope this relatively lengthy video was useful for you, that you learned something useful. Thanks for the lesson.